Welcome to Structural Integrity's webinar on monitoring damage, tracking inspections, and knowing what to do next. This is Freeman, and for those that don't know me, I'm responsible for the business development in SI's fossil combined cycle plant market. I'm going to be your host for today's webinar, while Jocelyn Wake from our Marcom department is also on the line to help facilitate. She's going to keep us from going off the rails. If you haven't already done so, can you go ahead and start the recording? So those who are participating will be recording this, so if you want to go back and watch this or share it with some of your colleagues, feel free. Now, before we get started, I'd like to point out the Q&A button. You should be able to find it on the WebEx toolbar, which is also known as the control panel. It moves down when you hover over to the top of your screen with your mouse. So during the at any time during the presentation, you can type those questions in. We'll be able to answer some as we go, but for most of them, we'll probably wait until the end of the webinar. And you all muted because of the number of people that are participating today. We to facilitate this, we have you all on mute. So that you won't be able to actually speak, but feel free to use the Q&A. Those of you that aren't familiar with structural integrity, I want to say we've got a long history of preventing failures to power plant equipment, such as piping, headers, turbines, and boiler HRSGs. I'm glad you joined us today to learn how we've taken our years of experience and incorporated that into the PlantTrack software. During this webinar is to highlight the value that is realized when data is used for lifecycle management programs. It's organized in a way that helps engineers or analysts obtain knowledge by first understanding the data and second, connecting it both geographically and historically. And we wanted someone to demonstrate the software that has used it from a customer's perspective or on behalf of an equipment owner to demonstrate how it's used in an asset lifecycle management program. And so Ben Ruddy has volunteered. He's one of our consulting engineers from our Material Science Center in Austin. So he's driving the demonstration today. He's been a user of the software for several of our clients and also managed countless projects related to failure analysis on NDE and risk-based inspection program development. Before he begins, though, I'd like to turn this over to Ulrich Juarez. Ulrich is a PlantTrack product manager, and he can give you an overview of the application. Based in our Charlotte, North Carolina office and is manager of our data and analytics department, which provides stress analysis services and software solutions to many of you that are on this line, actually, we have used those services. So I'll go ahead and turn this over to you.
Yeah, thank you. Yeah, I just really want to spend 2 minutes and 2 slides on before we hand over to Ben to walk us, really give us a live demonstration. But I want to talk just a little bit about the benefits of why we use a system like PlantTrack, and also a little bit about the bigger picture philosophy as it relates to all the different data sources and types that we have in our power plant and the different component types and assets, and how we can make use of that, and how can PlantTrack help us in making use of that. So with a system like PlantTrack, I'd say the simple answer is we sleep better at night. We think you can do so for several reasons, but maintaining your asset lifecycle management, we think we can help you by providing you a system and all the data in one accessible place. And I really want to emphasize the combination here of one and accessible, because it doesn't help us if all the data is stored in one place if it's not accessible to everyone that needs access to the data. So to make that possible, we designed PlantTrack as a web-based solution. Web-based meaning all I need is a computer with a web browser that's connected to either the internet or the intranet of my company. We offer 2 different types of solutions. We can host PlantTrack on behalf of our clients. We have a cloud server. We can host all that data, and then utility users can just access that through the internet. It's a secure internet connection, HTTPS. We can also offer that for those of utilities that might have maybe a little bit more concerns with that. We also can offer PlantTrack as a solution hosted within your network. It still serves as or functions as a web-based technology. We can access it with a web browser through the intranet, but it's within the network fully contained. So I would say that's one of the unique features of PlantTrack, that we have that flexibility to our clients, that we can have them hosted or we host it. But the important thing is you pass all that data, and whoever you grant permission to access that data, they will have access to that data. Another important point is The ability for you to see data graphically becomes very, very, very important on assets that have lots of components and details in them. And typically in a power station, that's what we have. We have lots of component types we want to track. So we have components like valves, in steam lines, instrumentation ports. So we want to be able to track that. If we all had that just in a tabular format in spreadsheets, it'd be really difficult to us to understand and recognize where these are. So PlantTrack gives us a graphical interface. We can visually see where these locations are, and then can also visually see what needs to be done when. Another important point I would say is really that we don't just want to store data. We really want to turn data into information and ultimately into knowledge that helps us to guide future decisions. And PlantTrack, as we see here in a minute with Ben, has some unique data mining, data filtering capabilities that help us in that. And lastly, I want to point out that what you do with PlantTrack, and I think that's really where PlantTrack is very unique, is you can monitor your assets based on actual operation and see the impact on asset health. And that's something that we implemented over the last 3 years with PlantTrack. In addition to our offline data storage capabilities, we have now capabilities of doing actual online damage tracking. Before I hand over to Ben to show us how that works in action, I just want to talk about one slide about the philosophy behind data asset management. So if you look at our assets and if we maintain them, we really have to consider 3 types of data, which classify into the first one into specification data, and any information we have about the as-built condition of our asset. So that could be materials, geometries, anything that's specified when it was built. We want to be able to store and access that data. But then there's another type of data related to that, which is what we call events. And that's anything that happens to my asset over its life cycle from that time when it was originally built. So it could be anything, inspections, analyses, prioritizations, anything I do at a certain point in time. I want to be able to capture that data, and I want to relate it to these components as they're specified. So these 2 types of data we categorize as offline data, because anything we can collect while the unit is offline or while we're not even on site. And then the third component that we consider certain data source or time-dependent type, and that's what we classify in the monitoring, and that's continuous operation and any data that accumulates from a continuous operation. So that's typically like process parameters that we collect through sensors and store in data servers, data historians, or data archives. So we're online. If you can access that data, make of it, run calculations on the fly, and determine life consumption based on these actual operation in combination with knowing our as-built conditions and anything that happens with events. Then I really have a rich set of data, and if I bring that together in a useful and sensible manner, I really have a tool in place that helps me to plan and predict future action. So with that said, I hope it'll all make more sense for you as Ben walks us through that. But with that said, I'll hand over to you, Ben. Ben, let's go.
Ben, yeah, you might be
mute. So it's a good start, but I apologize for that. Appreciate that, Ulrich. So one of the things that I'm going to try to do today is to just go through this as a user. I'm going to maintain an SI hat because I've done this for a lot of clients over the years, and really being able to take their data and kind of help them manage it. Because we all know that, this is the work, and this is kind of where SI can come in and really help guide and provide that general support as staffing gets more reduced, as we're kind of seeing with the industry. So an email just a little bit ago that provided a link to the overall agenda of what I'm going to try to go through in this window. I'm going to kind of touch on a couple of items here. I'm going to kind of jump into the dashboard, and I'll show you all this here in just a second. But I'm going to jump into the dashboard. It's kind of like it's like the launching point for where we kind of get into all the data, and then transition pretty quickly kind of right into the interactive module and try to show you guys how you look at a system and kind of see activities as we go through the life cycle of that particular component, that particular system, talking about things like prioritizations, developing scopes of work for inspections, tracking actual action items, and following up with that if you do any kind of actual online monitoring, and managing data as a whole. We'll also touch on inspections for supports because that's very important. So to go through that, as succinctly as I can while not losing anybody, because it's a lot of stuff to cover. And then what I'm going to do is I'm going to come back to the dashboard, and I'm going to kind of touch base on some of the different widgets and then the file manager aspect. So with that said, I'm going to hop out here. Okay, so this is the dashboard. So one of the things that I'm here, without getting all these different widgets and again the file manager, I'm going to start with the interactive display. So kind of go through this as a user. I'm going to maintain my SI hat, show what it is that I would do in helping a client kind of manage their system. So today we're focused on a grade 91 system. We're going to focus on a main steam line and grade 91 material. I'm sure most of you on the line are somewhat familiar. It can be kind of a problematic material. We're going to focus on this arbitrary site, the San Jose site, and their Unit 1 piping. So I'm going to go down to that particular system, and I'm going to go ahead and jump into this interactive display. As loading here, one of the things that Ulrich talked about was the different types of the offline data. I'm going to focus on the offline data right now, and then we'll get to the online data here in a little bit. So in data, we have the specifications, which is basically kind of laying out what the system actually is. Drawings, the actual component material, the geometry, having all of that in space right here is a very powerful tool. And I think one of the things we joke about from time to time is one site, and we'll try to collect all this data and try to manage it and try to understand what the system looks like. Well, that data is down in a dark dungeon in a random file cabinet. So this is kind of taking you and putting it up into the cloud, housing it in one nice space. So what we see here is the global main steam system, and it's a combined cycle plans. This is really, like Ulrich mentioned, is really important because there are a lot of components, a lot of the piping runs. It can be very complicated. Having this in a visual perspective can be useful, and I'll show you that. So specifications and events, the two blocks that Ulrich touched on. The specifications are kind of outlined in this particular structure here. And so if I dial down, knowing that we're focusing on the main steam, well, we can see these components, okay? And the components we have outlined in this particular demonstration are welds, tools, hangers, and those are that we have added right now. So you can in small diameter connections at some point, but we just didn't do that for this demonstration. So welds, this goes all welds for this main steam line, which is powerful because if you're looking for 1 Bravo weld 10, well, weld 10, you got to pawing, you got to look at all that stuff. So this again is where everything is housed. So if I wanted to look at a particular component and look at specification data, I can either dial down to that particular weld here. So I'm going to focus on this weld 24. And the paint here shows me all that specification data. We can see that this is saddle weld. 91 systems can be a problem. We can just see the type of, it's a field weld, the type of component. If we have any information on the post weld heat treatment. So there's a lot of information that we can add here to really kind of start to build that baseline structure for your system. So what I want to touch on as well when we talk about the specification area is you can add in attachments. So I'm going to show you, again, just a demonstration. So I have an actual saddle weld, but ignore the ID on the photo. So if I pop here, hopefully everybody could see this. Hopefully there's not any significant lags. So this shows you the component. You can see there's a saddle weld, an OLET, in this case is a lateralette, connection to the main pipe here. So it's also a very powerful tool because then it can show you, if you kind of forget what the component looks like, now photographs, drawings, etc. So again, this is the kind of global specification where you can start to build that baseline structure. So same, if we go to, we pull up spools or we pull up supports, same concept. About drawings, this is also very important. You can house drawings, and these are housed on like the global Einstein level here. One of the things we did is just add in drawings here, and then this here, so you can kind of start to see where I'm going with all this and the functionality of having everything quickly at your disposal. So what I'm going to try to do now is I'm going to kind of work on the events block. I'll work on specifications and then events. So events is essentially where you have prioritization events, inspections, you have stress analyses, et cetera. So all different types of activities where you start to then record that particular data for a particular component, be a weld, spool, a support, et cetera. So what I do now, try to stick with the agenda as best I can, is go through kind of like a general user scenario profile. I'm going to kind of walk through what it is that I try to get clients to do and kind of streamline their cycle of that particular system. So I'm going to a lot. You'll hear me talk about graphical display, filters a lot throughout this particular demonstration. And that's kind of the importance of PlantTrack, is being able to see things visually so you can make pertinent decisions. So me hearing filters over and over and over again and graphical display over and over again, but I think you'll see, hopefully, the usefulness of that. So one of the things I'm going to start with is risk-based prioritizations. So when you look at a particular system that has, plus welds, in some cases 300 plus welds, where do you start? Where do you start to try to understand how to, kind of prioritize where to look to kind of get ahead of any damage that will occur? I mean, these systems, they design as best they can, but as I'm sure most of you are well aware, that damage does occur. Issue size, that are kind of common industry issues, et cetera. So one of the things that SI does is we use this Vindex system, which is basically a risk-based prioritization that incorporates two things. It incorporates the Vindex, which is a vulnerability index, and essentially kind of in layman's terms, that's a score that gives you the likelihood of failure. It's the life fraction expended, and that's derived from a couple of things. So to kind of the weld operating stress, the material type, the strength properties of that material, operating conditions, service history, any known industry issues, and then any known material conditions that you might have from prior inspections. So the second pertaining to this is a consequence. So SI on site, and we'll walk the system down to the plant engineer, walk the system down to the operators, and try to build a kind of a global map for where have areas of high personnel traffic, because then essentially that's your consequence. It's a safety aspect. So the index and the consequence gives you the overall risk profile, which is a score from 0 to 100. So go ahead and I'm going to run one of these filters. It's going to give you a graphical display. So say we've come in and we've done this assessment and we've generated a risk profile. So we're going to look particularly at the welds. So a bunch of different filters, and these are essentially logic-based criteria that takes some of the data that's been entered and it then can display it graphically how you see fit. It's all customizable. This is not, there's not just select options. It's very customizable based off kind of your standard logic. Go to the overall risk. Okay, let's see. Plot that. Okay, so now you can see here, again, score from 0 to 100, 0 being low risk, 100 being high risk, and the colors are kind of, posted in line with that, red being high risk, orange being pretty high risk, and so on and so forth. So what now is that you can see from a global perspective where your areas of high risk are. So if you go through and build a scope of work, now you can sit here and say, okay, well, I know I have limited dollars for this upcoming incentive. I know that I have a limited outage window, so I can, me personally can work with the engineer and kind of start to develop a scope of work that fits within their budget while still capturing areas of risk, areas of high risk. So before I come into the scope of work development, I want to touch on a couple of important things. So this particular prioritization that I touched on is, size approach, but it's important to mention that if you guys have your own internal prioritization system or you use another provider, that's totally fine. That is perfectly acceptable, and all that data can still be added here. So I just want to make that very clear that this is not you're tied to SI. This is essentially just trying to give you the means to take the data that you acquire and be able to see it graphically. So we've come through and I've worked with the plant engineer, whoever is involved in this activity. Decision that, okay, hey, we want to look at, here where that OLED is, look at the steam turbine connections, and then we will look at the HRSG connection. So that all captures the risk. Now, we do realize that there's an expansion loop here that we're going to, not do any of that at this particular inspection. So we have to, so the plant has to assume some level of risk in that case, but, they also have to factor in budget, and all that. So require significant scaffolding, so that's why that kind of got pushed off. But so as you can see, we're going to kind of move forward with that particular scope. So I'm going to show you what I think is very powerful, really functional tool. I'm going to show you how you can kind of start to add in data to PlantTrack. And I'm not going to go through the full, this isn't like a training exercise. I'm going to kind of give you just a flavor for how that works. So what is really neat is that you can use Excel. So if I come here and Excel, you create a secure link up to that particular PlantTrack site. So I'll log in here. Okay, connected. So now what I can do is I can go through and I can download all the welds in my system. Okay, so I'm going to go to San Jose, Unit 1, main steam. And again, this is going to be big, so hopefully I'm not going to lose anybody, but I'm trying to show the gist of how you get information into PlantTrack. So don't worry about all the details here. I'm going to find my welds. I'm going to go down to, I want to build an inspection template. Okay? Great. For the most part, Excel is a pretty universal tool at this point in time, this day and age, I guess, if you will. So you can solve the functionality of Excel. I can create filters. I can come through and kind of clean all this up, and then through here, and I can sort. So I know that, for example, I want to look at weld. So one of the things I can do here is say, all right, for that particular weld, I'll do mag particle inspection, and I'll create another little record, and I want to do LPA, which is linear phased array, and so forth. So I can start to kind of build. I can delete welds I don't care about. I can start to just build an overall scope of work. So then what I can do is I can take this spreadsheet, which is now my inspection template, and I have all of the welds in and the methods for each weld published in this spreadsheet. So this can be given to us, structural integrity, if we're doing the inspection, or this can be given to another provider to then populate and then have that information uploaded into PlantTrack, which is basically just come here and you do data upload, and it sends it up back to the site. So I go through all of that because I've already kind of listed all of that up in this particular application. So you have that sheet, which can be provided to your providers, or you can use yourself. If it's something that you're taking care of internally. So let's say, you want to have a meeting, with the plant manager or with your directors, senior folks, and they say, show us how you came to this and show us what the inspection scope looks like. So again, you can use these filters in kind of a graphical display to say the inspection scope that I came through and I built. And what this is now, you can see, actually that's incorrect. So that shows all the welds that you're going to look at are highlighted or essentially not grayed out, and they have a little indicator underneath each showing the different methods. Again, this is very customizable. You can tailor it and adjust how this is displayed to how you see fit. So moving to the next thing. So we've got this scope of work built. Now we're gonna go through and actually do the inspection. So how does that work, and how does that data get displayed in here? So we have these welds that we're going to look at. So we've come through, we've done the inspection, we've done the particle, we've done all of these methods to these particular welds. So when that's all said and done, okay, well, findings. What are the things that I need to worry about and kind of need to stay ahead of? So again, I can come here and say, ignore 2015. This is arbitrary. So I can come through and say, show me that 2015 spring outage ND indications. Through that. Okay. So now what we see we have a couple of welds that came up with HD hardness. So again, grade 91 hardness is a really important method to utilize to kind of really assess the state of that particular material, whether or not it was maltreated. So you see that we have a couple of welds that came up as like a flag with hardness testing, and then with two welds, this weld 24, which was that problematic OLED, just knowing that's an industry issue on my behalf. So it actually was a problem, and then we have this particular here where I'll touch on that here in just a second. So one of what's neat is that if we say, okay, we know we have some hardness flat that popped up. So okay, what these values were and kind of show the general range. So I can go through here and say, okay, so the hardness values that we got, we have kind of, SI has our, standard range, what we consider hardness to be acceptable and what we consider hardness to be unacceptable, so that these filters were built accordingly. Again, if you guys have your own internal procedure, that can be customized to that. So I think this is a really powerful tool, especially as you go through, as you kind of build on, you're looking at all your welds, doing all the hardness for each weld, especially 300 welds. This can start to kind of give you a good picture for where maybe you had some issues, with post-weld heat treatment or just overall, fabrication issues from the buyer. So, being said, I want to go back and I want to focus on, we'll go back to the NDE indications. Focus on these two welds here, this weld 24 and this weld 8. So one of the things that's neat is that if I go through and I can filter here and basically say, okay, look at weld 8 and then weld 24. So again, coming back to that block that Ulrich mentioned on records and events. So this is housing each event for that particular method. So if I look at it and I say, okay, weld 24, show me what the mag particle indication found. So I have a bunch of attachments here. I'll just show you real quick. This is really neat, and this is where I think that this gets me excited because I think there's a lot of really cool things you can do, and especially if you have a provider that takes really good documentation, you can store all this here and see this really quickly, and assuming you label the files appropriately, kind of really get to this information fast, and it provides a value. So this shows that saddle weld, shows the damage that's occurring in the Type 4 zone. We know that's a particular problem. I won't in too much about these OLEDs. I've seen a lot of issues with these OLEDs over the years. They can exhibit service damage pretty early on. We're talking 3,000 hours. But I won't go off into the deep end, even though I want to sometimes. If you guys want to reach out to me afterwards, you're more than welcome. So again, this mag particle. If I go back and say, all right, show array, same concept. With information, you can start to see that some of that was captured from that particular method. And I also want to show the replication as kind of the final deal as well. So hopefully loading, we're not getting any lag, but this is click creep rotation in grade 91, and this right here is bad, very bad. So this is all captured. So one of the things that, to this particular weld, if I transition over to weld 8, we could see we had hardness, which came up as 150 now, which is pretty problematic for grade 91. And one of the things that was unique is that when we started inspecting, we note the spool, this other spool here, let me highlight this here, was found to have globally low wall thickness. So either something happened from the manufacturer, but having a low hardness and a low wall thickness can really cause, a problem from a creep standpoint, because now the pressure-driven hoof stress on the spool is going to have a more profound effect. So, okay, let's grade all this stuff. So what now? So what do we do now? All these, we have issues. So what I came in here and I created a 2015 spring outage action filter, and all kind of just placed like the general notes that came from this their inspection. So knowing the OLEDs are an issue, kind of the common practice is to go through and replace an integrated forging, fully integrated forging, kind of get rid of that saddle weld. So the plan made a decision that they were going to move forward with that by the fall of 2016. So they made a localized repair and go forward and make that wholesale replacement during their next outage. Now about this other weld and the spool, that's different. We didn't see any obvious damage. I mean, obviously the hardness was low, the thicknesses were globally low, but there wasn't anything popped up that really said, hey, there's something going on here. But get that, we know that there's going to be a reduction in life from a creep standpoint, and that generally reduced wall and the low hardness. So one of them to avoid is that this be a nightmare. So one of that we want to do now is we want to say, okay, and place this particular spool, okay, this spool on a monitoring protocol. Excuse me. So as Ulrich mentioned, the third component is this online data. So the online monitoring that we do from a creep and a fatigue perspective, I'm going to focus on the creep, but the fatigue aspect is similar. Takes into account algorithms that basically use actual operating temperature, pressure, flow rates, etc. That's live, and I want to emphasize this live. So if you know, it's pulling data right now. So it's not, this is as you see it as you're operating. So it pulls this particular data from the historian. So Pi is a real common example. So basically take this application and link it to the data historian and pull this data, and then combine this actual operating data with field-affected data. And then that's really important. So you take things like, for example, component geometry, in this case the spool. The wall thickness is globally low, so we take it into account. All things like material conditions, again, low hardness. So you too, we're then able to kind of calculate a level of damage, and you can try that into the future. So all really is trying to be proactive. It's how can you stay ahead of that are going to arise. And I'm a huge proponent of that. I mean, I know in particular it's involved with a lot of things that just, fail or things that happen that we're unaware of. The goal with all this stuff is to try to really be proactive, so that way it can be managed appropriately, so to avoid this risk. So one of the things I'm going to do now is I'm going to transition and kind of show you this online monitoring application. So I'm going to right now on the creep perspective. You see some of these other, we go back to this navigation pane. We look at tree structure. we focus on this particular spool, and you see this little C next to it. So that is essentially the creep monitoring application. So I'm on this here. Guy open. Okay. Again, you'll have to kind of ignore the dates. Again, this is just a demonstration. It's obviously not live. We're not connected to any data historian, obvious reasons. What's cool here is you can start to see, as we go back, we did the inspection in, March of 2015, kind of get a sense for, okay, fast forward 2 years, your life's changed, you have kids running around, and you think, well, man, what happened to that particular spool? Where are we at? And if you have this online monitoring, you kind of start to, you lose sleep at night. So now you can say, okay, well, we've started to accumulate some pretty good damage, but it allows you to then be proactive and say, hey, you know what? We've been able to kind of run this thing, get the way we operate. We're trending, pretty steady. We can start to make a replacement. But that said, it comes through and you adjust the way you operate. Say, the markets change. Say, you lower temperature, or maybe you even increase temperature. So all is going to affect the dish consumption, the creep life consumption. So this is powerful because it takes burden off of having to pull data, having to run a study, et cetera, et cetera. So this is all live. It's all proactive. So fatigue is the same concept. So we use the transmitters that you guys have in place now, your thermal wells, your pressure taps, et cetera. And fatigue is the same concept. So we'd use fatigue in cases where you have large thickness conditions like valves, T's, locks, et cetera. One that's also really powerful, and I'll get back to this on the dashboard here when I kind of close this interactive demo, is the fact that you can get set notifications. I talk about 2 by, and kind of, whoa, what's going on? Now, with this particular monitoring application, notifications can be sent up on a particular damage threshold that you as the engineer, as the owner, want to set. So for example, if you say, I want to be notified, every time I get 10% accumulated damage, I want an email sent to me. This is really nice because, again, it just takes the burden off of having to go in, even go in and look at it within PlantTrack. Now you know that it's in the background, and I'm at 30% damage consumed. I'll get a notification when I'm at 40%. Right? I know we want to kind of make some actions to either replace it at 50%, whatever the case may be, so you can kind of breathe easily at that point. So we have a temperature monitoring, and a temperature monitoring is, in my opinion, is also just as powerful. The one slight difference between temperature monitoring and the creep and fatigue monitoring is that you need actual thermocouples, and I'll show you that here in just a second. So let me clear this out. I'm going to jump over my spools here. So again, this is a demonstration. We have this a temp spool here, which again the system is not correct, but just bear here and kind of work with me a little bit. So one thing is that you care about localized transients, and a lot of times in inner lines, bypass lines where the stations are, a lot of times the thermal wells, located really downstream. So I'll kind of show an example here real quick. So this is a bypass line. Again, doesn't mirror to the actual application, but again, this is just for demonstration purposes. So you see here that we have this bypass valve. Let me my pressure reducing valve, and you come along here. Well, the nearest thermal well is actually located way downstream. So you really care about areas here where you potentially have pooling or impingement. So one of what SI will come and do is we'll come in and generally place areas where we recommend that surface-mounted thermocouples be placed. So that said, we want to annotate that. Those would get installed, and it would kind of be the same process from there. They get routed to the historian. We would link to the historian. Now, generally, what so that's kind of a pad style surface-mounted thermocouple. Pretty forward. Of insulation removed, and you need to prep a spot, but again, pretty straightforward. So that said, they have all that. We have the thermocouples in place, and it's now we can come in and press this A for a temperator, and there it goes. So that is going to load, and again, this is the same kind of this concept as the creep and fatigue monitoring, in that we track particular, we track the actual top to bottom temperature differentials, and that kind of establishes, we set criteria to then basically flat count those particular events that exceed those differentials. And that kind of, using that type of logic, we can kind of differentiate between pooling, impingement, et cetera. And this is all really neat because, again, it works with you as you go through operation. So you can look at and say, okay, well, how are my spray stations actually configured? How are they operating given that particular load profile for our system, for our unit? And so this can be very powerful in the sense that you can go through and then just simply make logic adjustments, and see, okay, well, maybe in this here we had a bunch of issues, and you made some adjustments. Everything, and then we started adjusting the unit. We ran the unit a little bit differently, or something happened, and we started to have more issues. So this just allows you, again, to be proactive and to kind of see things live and make adjustments ahead of that does and will occur. Last but not least, I want to go back to supports. So I think supports on certain occasions can kind of be talking about, and they shouldn't be, because they're really going to affect the overall movement of the system, the way the system kind of redistributes the stresses over time, and tracking this is a very powerful tool. So, again, same concept to the components like welds and spools. You can see the hangers out here, and I'm going to focus just on one particular support. So, again, one of the things we always ask for is, do we have detailed drawings? Do we have general photographs of that support? So you can see the attachments. So it's a variable spring support, kind of a global photo. And then I believe this is the drawing. Yeah. We have the drawing here. So again, you can see that you have a details for all, how many hangers? All 50 hangers. Well, are they all in the same spot? If not, so you can go. If not, then you can go through, work in, define it one time, get it all into PlantTrack, and then point. You come 3 years down the road and you say, well, I want to look at the variable spring 52. So let me go back to that cabinet and find that drawing and find photographs. So it's all here and it's all tied to that specific support. So again, very powerful. So I'm going to let's see, run a filter again. This just shows one particular way you could show, have actually, you need to look at all. And this shows, you did a support survey. You can note areas where the supports were bottomed out or where there was, inadequate guide, appearance of the different guides. Again, you can start to really, it's neat because you can kind of look at your system and say, well, man, I maybe have only hangers that are malfunctioning or starting to look, out of place in a certain area, and start to track this, year over year or every couple of years to kind of get a sense for how your system is moving. Then go through and you decide, well, I want to do a creep redistributed stress analysis. All this information is very powerful, to be incorporated in that analysis. You can really, assess and kind of assess out the system in that are currently present. So, with that said, I'm going to go through kind of the last bit here and jump back to the dashboard. So here on the dashboard, I'm going to go through and show a couple quick, and then I'll touch on these widgets. The widgets are these different panes here. So what I think is really, really, really powerful, and this kind of ties back to all the stuff talking about housing data and keeping it organized. So this file manager is basically, your pseudo structure up in the cloud that is obviously linked to all of the areas up in the interactive display. But it's housed here as well on the dashboard if you just want to kind of pull something up real quickly. So say we go through main Steam, and I know that I did some grade 91 life studies. So I go quickly and say, okay, here it is. Here's the report on the grade 91 life study. And there you have it. So you can see that, this is, again, hopefully this is lagging for everyone. This was a study that was performed based on the hardness that we had found and that we didn't do online monitoring. This is a little study that was performed. So anyway, so you have that type of thing. And again, this can be structured however you want. This is optimizable. So and this is just a really neat way to make sure that everything is put in one place and structured appropriately. So we'll just here to the dashboard. Won't open this here, but you can see on the left we have this user guide, and that's a page document that gives detailed step-by-step instructions for how to navigate to all these different areas, how to build filters, and how to use that logic. So again, I think that was really, really nicely done. It's very clear. So I'm going to start from the bottom here. I'm going to scroll down. So again, filters, this widget just shows the filters that you've generated, and what it'll do is if you click on it, it'll take you right to the interactive display, and it'll essentially load that graphical display for that particular filter. So kind of just a quick way to jump into the interactive display. Quick list is basically for creating like a of information, mostly in an Excel format. So if you go through and want a list of inspections that were performed that contained welds with service damage, you can do that. You can kind of use logic-based criteria, and then you can export that to Excel in a nice, clean format. So that's a quick way that if somebody comes to you and say, hey, can you give this to me real quick? You can run in, make a quick list, and then export that out and be done. So if I scroll up here, kind of jumping back to the top, you can see the latest documents uploaded in reports. Explanatory reports is, reports. So that's just a quick way to find all the reports that have been done for your system. Same as documents uploaded. You can see here this surface-mounted double. So if I click on that, there you can see that thermocouple. Go to the top here. Then we kind of get to the meat of the dashboard. Obviously the navigation pane that allows you to kind of get to the area you want to focus on. So you go to the main Steam, and once you select the system you want to focus on, that basically pops up in the interactive display. I would click that, and it would launch this browser here, and we would go from there. The last thing, but not least, is kind of global snapshot of your online monitoring application. Again, this is a demonstration, so this is just for kind of visualization purposes, but this is neat. You can come in here, you can set notifications for when you want to be emailed, and then you can focus on, main Steam and kind of see where we're at for the overall tracking for the given component. So that being said, I know we covered a lot. Again, I tried to jump through just some general user type scenarios for how you manage your system, from a high level perspective, and really how you can use PlantTrack to kind of look at this stuff graphically, and then be able to move forward in the future and have kind of that peace of mind that you have everything housed appropriately, areas that need it monitored appropriately. So that being said, I'm going to hand it back. I'm going to jump to this little presentation here real quick, and we're going to back to
Ben.
Matt here.
Hey, want to open this up and remind people that there is a Q&A panel that you can submit questions. So we're going to open this up for questions. If you want to go ahead and post those there, get that. While we're waiting for the questions to come in, I will tell people that I believe we have recorded this. So as long as the recording comes out okay, then we'll send out an email later today or tomorrow with a link back so that you can watch this recording. So there is a couple of questions that have come in, and this first one, Rick, I'm going to throw to you, assuming that you've got your mute. And the question is, can you rate signals from non-SI sensors? I think we were talking about online monitoring, and maybe we want to clarify where the inputs come from for the online monitoring.
Absolutely. So we can type of sensor data that is stored in a plant's data archive or data historian can make use of. So we would create an interface. It's very the neutral interface is available. A typical data historian is the PI system from Microsoft. That's what we work with most. There are a few others that works too. But a typical connection would there be to a PI data historian. There's an API, a web API interface. It really doesn't take much from our end. Our software has an API interface, so we can just, that's the neutral interface, so we can just make them talk to each other. And we just need the data owner on the utility side to publish the tags that we need, and then we can make use of them and use them for our calculations and online tracking.
All right. Great. And maybe Ben, I'll throw this one to you. The question is, what info is required to be provided to put together an accurate plant track for the piping systems?
Yeah, that's a good question. So, one of the things we would start with is trying to get just the general isometrics, the detailed ISOs for the big manufacturer, the EPC provider, and then the steam turbine manufacturer. In the case of a combined cycle unit, but basically the different providers, we try to get those detailed ISOs, any shop and spool drawings, so that we can kind of look at the system as a whole, start to actually build that model, that 3D model that we can then upload to PlantTrack, and start specification data. So that's kind of a good starting point. A lot of times if we're doing these type of assessments, we'll come on site and we'll help guys kind of work through the data and try to do that, in conjunction with you guys.
And I think what I'll add to that, Ben, is one of the things that's unique about the PlantTrack software versus other things that the software applications that use drawings is we can use CAD drawings, but we can also use an image, whether it be a JPEG or a bitmap. And so if somebody has an ISO that's already done, even if it's just in the back of the envelope and that they're looking to end quickly, we can load that on as well. And it may not look as pretty if it was drawn on the back of an envelope or back of a napkin, but the software does work so that we have quite a bit of flexibility with doing those implementations. So I think as you described, that's what we typically ask for, but do things with less data as well.
Yeah, good point.
Yeah, so there was another question here, and Ben, I'll throw this one to you as well because it has more to do with operating. You showed, and the question is, you showed how ND data can be loaded using Excel. Can hangar inspection data be loaded the same way?
Absolutely. So I worked through that Excel mode, and it's when I selected welds, it popped welds, and that kind of created my weld inspection template. The simple adjustment would be to come in and select supports instead of welds, and create my inspection template for those supports. So yes, it's the same concept, just a simple click of support. So I would add real quickly, it's very powerful when you're using, when you're uploading a lot of data. But if you only have, you want to adjust one quick thing, like say you have a variable spring that you want to adjust, say some of the specification data needs to be updated just for one hanger. You can do that actually in the interactive display in that specifications pane, actually in the module itself. So, yeah, now you do it all. You yourself if you wanted an interactive display, but Excel is useful.
Okay, great. And then, so Ulrich, this next one I'll throw to you is the question is, we will be building at least one large combined cycle in the coming years. Do you suggested instrumentation to include during the design construction phase to help facilitate analysis and monitoring?
As Ben alluded, the one online tracking module where we typically need some additional instrumentation would be a temperature damage tracking. And I would say that's of special interest if you have a combined cycle plant, because temperatures are a recurring issue there. So that'd be a perfect time to add some additional instrumentation during the commissioning phase. And we'll support that. We'll provide instrumentation guidelines, and we'll mock up drawings and tell you where to put them, and put a document together. So whoever does that, puts that instrumentation on, has good guidance. And then once data is available and gets transmitted into the data historian, we can connect anytime, PlantTrack anytime. Even if we do a PlantTrack implementation a year or two later, or connect it with the online damage tracking module, we can just pull that historic data in because it's recorded. So the most critical part would really be have a good start and putting these thermocouples in at a convenient time, which would be during erection, and then we can implement PlantTrack and online damage tracking later. For the other modules, creep and fatigue, typically there's all the instrumentation available already, all the process parameters. We need temperatures, pressure, and steam flow rates. So this is usually readily available, and we can just use it and activate these online damage tracking modules.
Another question. I have a brand new plant. PlantTrack work with a brand new plant. So it's basically, I think the question is related to new construction, and is it applicable for a brand new plant?
Yeah.
Yeah, Ben, do you want to please?
Yeah, sure. I'll jump in here. So I've had a couple cases where we've done similar things where we've come in at the at day one, or even day sub-zero, whatever you want to call it, prior to commercial operation. And if that's the case, this is where this is really valuable, because you can, again, like I mentioned, start on have a good baseline, a good structure built, for your system, so that way you can kind of track it into the future. So yeah, absolutely. I mean, there's no, this implemented it, like Ulrich just said, at any time. But if you want to get started and establish that baseline appropriately, you can do that. Do that now if you'd like.
Yeah, and to add to that, we actually have quite a bit of interest in that, and one many reasons, but one is that it helps us to be compliant with the code, with B31.1 in the case of piping systems, which means that we should have a data management system in place. If you're able to collect all the data steadily from day one, we're very well in line with the code B31.1. So that's I would say an additional advantage of just starting early on or from day one.
Yeah, that's a good point.
Okay. All right. Well, hey, we've come up to the end of our hour here, and everyone is busy, so I don't want to go, but I do want to encourage, if you have any other questions, please reach out to any one of us. You see the screen right now. You have our contact details. You can also reply to the invitation that we sent you for this webinar, and we'll get routed to one of us to respond to you. It is recorded, so you will get an email back from there. But with that, we for your